you. First of all, I think we have to thank our technical support and the video streaming team that they have been working for the whole morning to try to set up the live streaming for us. Yay! Give a round of applause. Thank you. And I think it's time to start now. If possible, try to sit in the seat in the center of this room so latecomers can sit at the sides. Thank you. And first of all, good morning and welcome to day 2 of PyCon Hong Kong 2017. I will be your MC of the morning session. And first of all, I'd like to pinpoint that there are 3 tracks that will hold simultaneously today, like yesterday. So the first, during the morning session, LT16, which is this room, and the room next door will be doing the same channel of talks. And in room P4704, we'll be having a development sprint, which will start shortly after the announcement here. A few announcements to make. We have donation that you could purchase a t-shirt, which is this one, the blue one, for $300, and a calendar for the coming year for $50. And if you want to waive tax or you need a receipt, please feel free to go to the counter and tell our staffs. We are more than helpful to give you a receipt to waive your taxes. And also, for the seats arrangements, like yesterday's, we are having free seatings, but please try to sit in the middle if you come first, so that latecomers could sit at the sides. And also, if you are going to the loo or you want to switch rooms, please be careful of your personal belongings. We've heard that some participants have left their laptops or wallets in the previous venues, and then they have to come to find us for lost and found. So please be really, really careful about your personal belongings. Try to keep them safe with you. And also, as you can see from the screen, there's a link. We are having a Gitter chat room, which you could get into this chat room for this whole day, give us comments, or if you want to share something or you want to help us to improve, please feel free to get into this chat room with this link. And we will try to do our very best to serve you guys. And okay, so this is somehow a wrap-up of the announcements. Are you ready for our session of today? If you want to go to the development sprints, you don't have to sign up in advance. you can just head to P4704, leaving from the exits at the back of this room. And then our helpers in the hallways and public areas are willing to like give you directions. Our helpers are all in this blue t-shirt. Just recognize us. So for those who want to join the development sprint, you may like proceed to the room now, which is P4704. Yes? It's like a workshop, and then you do hands-on tasks together. Somewhat like, yeah, it's a workshop, more like workshop than a talk. Yeah. Have you all like copied or tried to get into the link? The Wi-Fi password. Our helpers could give you. You could get to wi-fi.hk first. With Wi-Fi problems or other problems, any kind of problems, please feel free to find our helpers in blue t-shirts. I hope you haven't worn the t-shirt you've just grabbed from outside just now, so that we won't get mixed up. For the meantime, I'll like have a really brief introduction of the coming session. The topic is how to approach a machine learning problem with Python, which is, yeah, it's for like especially for YouTube like count prediction, and then we'll use Python to predict it, which will be presented by our speaker, Mr. Ayush Singh. We're doing the like tech stuff to try to warm up the projector and try to link things up. So I'll just continue with my introduction. And in this talk, Ayush will guide us through the pipeline in approaching a supervised machine learning problem by a task about predicting the like counts, like you have to put a thumbs up in every YouTube videos as usual. So the task is about how to predict those counts, those thumbs up in a YouTube video. And our speaker, Ayush, is a computer science undergraduate from India, which he is currently working as a research intern in Saraf lab. He frequently goes to give open talks in different conferences in his college and other community meetups, such as PyCon Hong Kong, and which mostly they are about data sciences, machine learning, and many other stuff. The slides are just not popping up. We'll just have to wait for a bit. Yay, okay, good. They're up. So,
Hi,
yeah,
am I
thank you.
audible at the back? Am I audible? Cool. So, hi, I'm Ayush. This talk would be about how to approach a machine learning problem using Python. So, I would be basically discussing a project of mine which was YouTube like count prediction, and would be talking about how I kind of approach this particular problem. So I'm currently a third year undergrad, majoring in computer science from India, and currently working as a research intern at Swarit Lab, which is a research group working on autonomous cars. So let's get started. So this is the general workflow or pipeline which I kind of followed for this particular problem. The workflow kind of can vary with the type of problem one is tackling, but most of the things which you see here remains the same, especially if you are tackling a problem using the traditional machine learning approaches. So let's see the problem statement first. So the problem statement is pretty simple. It's basically given a video on YouTube. We have to predict, or we have to predict how many like counts the video has got. So we have to predict that thumbs up like counts. So this would be a regression type machine learning problem, since the target variable which we have is a real continuous type of variable, and it would be a supervised machine learning problem, because the data which we will collect will have the specified input data and the particular labels assigned to it. So the first thing in our pipeline is the data. So data collection is the initial and one of the most crucial steps in the whole pipeline. So data is the key ingredient to any machine learning model. So at this step, it's really important to kind of collect as much data as we can, because we kind of don't know at this stage that whether which of the attributes or the features present in our data would be finally helping in the predictive power of our model. So talking about some of the sources for data collection, we have right now plenty of public and private data sets available, especially on platforms like Kaggle, UCI, and many more. But in cases when public or private data sets are not available, we kind of have the option for either scraping the data from the web or using some API services if they provide the kind of data we are in need of. So for this particular problem, so I didn't find any public or private data set which was providing the kind of data I needed. So I used YouTube Data API. So it was quite easy to use and provided a quite extensive data, especially the type of data which I wanted. So here was the first challenge which I faced. So YouTube being an enormous base of videos, so it was really difficult to decide that whether which videos to take and what all videos to take. So um, so on YouTube we have all the videos basically divided into 15 broad categories, like comedy, entertainment, health, and so on. So if you see at the YouTube request API, it kind of takes in as the video category ID and the time range for which one wants to get the data for. So I kind of took around 22 to 24K data points across all 15 categories from 2010 to 2016, and in the end I had around 0.35 million data points in my base. Yeah. So this is a screenshot of normal YouTube video page. So let's try to visually see and look at it and see what all can be visually find the data what all data can be seen from here. So things like count, which we have to predict. We have things like dislike count, the number of subscribers of the channel, then the channel name, the title of the video, the video duration, then the number of comments, and so many other things. So this was the data which I kind of finally ended up with collecting from the API. So I had things like the number of dislike counts, when was the video published, the title of the video, what was the dimension, whether it was 2D or 3D, and like these many, and some more, like what all tags did the publisher assign to that particular video. Then there were this all stuff was related to the channel the video belonged to. So things like the number of view count, the channel view count, when was the channel published, the description of the channel, and so on. So the scope to collect more data is still there. So we can kind of collect the comments. Like I didn't collect all the comments from here, and so there's still a lot of data which can be collected. It depends, finally depends on the computation power you have and what all resources do you have. So the next thing in the pipeline is data preparation, and this is the most time-taking step in the whole pipeline, and it's worth giving time to this particular step, because at this stage the data is not in a particular state that it could be directly fed into our machine learning models. So there is a need to kind of pre-process our data before we feed directly to the models. And the thing is, if we are gonna feed in garbage to our model, it will be giving us garbage out. So the first thing which we have is data pre-processing. We have things like formatting the data, where we kind of bring the data into a format which is easy to work with. So like in this case, I got the data in JSON format from the API, and I kind of converted it into a CSV format. Then we have things like data cleaning, where we either remove or fix the missing data. Then we have things like transformation, where we do data normalization or scaling. This kind of depends on the model you are using, because like not all models require this particular step. Then we have encoding data. So like all the models, they just understand numbers. So if we have some textual data, there is a need to convert that to numeric form before we can use that. And these are some of the libraries, some Python libraries, which come very handy and are really useful for this step. So next is data exploration and analysis. So the main purpose of doing this is to get some initial insight about our data, and to see if we could find some initial patterns visually by looking at the data or not. So we have things like univariate and bivariate data analysis under this. So the univariate is quite simple, as the name suggests, uni. We basically analyze each variable individually and do some simple statistics on the data. So here are some statistics on the continuous variables, like number of tags, then the how old the channel was, then video title length, and so on. And that's a categorical variable, which is the category ID versus the frequency, and so on. Yeah, and these are some of the screenshots from the Jupyter notebook, which I use for the data processing. So here are some of the things like, so in data cleaning, we have either remove the data which, in this thing, I'm removing all the data entries for which like count is not present, and that's the pandas code and all. And here I'm basically filling all the missing data with the mean value for the comment column. And that's encoding the categorical data. So like all these variables are categorical, and like they were in a textual form when I got it from the API. So we kind of assign a number to each of these and just encode to a numeric form. Yeah. So next thing in the data preparation is feature engineering. So as the name suggests, we kind of create or engineer some new features or some new attributes or features from the data which we already have. So the thing is to to utilize the data as much as we can and to get the maximum out of it. So so getting some domain knowledge about the problem and looking at how other people are basically doing this step for their own data kind of really helps for feature engineering. So I kind of went on to read some blogs and forums where the YouTubers have they have mentioned what kind of things they keep in mind before they publish the videos. So there were things like the title should be informative, crisp, and short, so that it is easily found out. So so I kind of tried to found the made a feature which was title length. and found the length of the title, the video title. Then we have tags. So like every time someone uploads a video, he puts some tags to the video, tags related to that video. So and that really helps in the search rank for that particular video. So I kind of found, so like from the API I got that particular tags. So I counted how many tags the person has uploaded, or yeah, so on. And then the number of tags in the title, number of tags present in the description, like the same thing. It also helps in the search rank and all. Then yeah, so then I had things like video month old, how old the video was. So like from the API, like we got the date of so when was the video published, we got that date, and that was basically in an ISO format, which the the model can't understand. So to find something out of it, so basically I found the number of months from that given date, and things like when was the video uploaded, the day of upload, and so on. Yeah, and the final thing in this second step, the feature preparation, is the feature selection part. So till now what we have done is created a pool of features, but the thing is that not all features are relevant to our model. So so in this step we kind of try to find the features that are most relevant and best describe the relationship between our predictors and the response variable. So it helps in like we reduce the dimensionality, so it helps in training our models fast, then improve the accuracy if the right subset is chosen and all. So I used these two methods, the filter method and the wrapper method. So this is simply running some statistical test to infer some relationship between the response and the predictor variable. So in our case, the the response variable was a continuous variable. So I had these two tests to run, which was Pearson correlation for continuous versus continuous, and then the Nova test for categorical versus the continuous. And in wrapper method, we kind of use the model itself to do the feature selection for us. Yeah, so this is the filter method, which is nothing but basically bivariate data analysis. So here are some of the the continuous variables, and that's the Pearson correlation formula. So you can see for some of the continuous variables like view count and comment count, the correlation is pretty good, and so we can see that with the increase, so there's a positive correlation, and with the increase in x, the y is kind of also increasing similarly to the comment count. But if you see the channel subscriber count, so the correlation is not that good. It's just, so the range of correlation is between -1 to 1, and so the positive means that with the increase of x, the y is also increasing, and negative means that with the with the increase of x, the y is either decreasing or vice versa. Yeah, so there the correlation was pretty small, so which showed that that feature is not that relevant. And then for categorical variable, like the date was uploaded, we calculated something like p-value and all. And then there's the recursive feature elimination, which is part of the wrapper method. So here, as I said, we take in a model itself and try to find or rank the features which we have. So I kind of use the random forest regressor for it, and used it to rank the features which I had. So finally, after all these steps, the feature selection steps, these were the 5 features which, on the basis of ranking, taking both into steps into consideration, these were the features which finally came out. So view count, comment count, dislike count, then the ratio of video view count to the how old the video is, the ratio of subscriber count to how old the or to the video count. Yeah. So yeah. So the final thing in our whole pipeline is the modeling thing. So here I will discuss about things like model selection, then cross validation, and plotting curves, and so on. So before that, let's look at some of the terms. what is training, validation, and testing set. So training set is the, as the name suggests, the set of examples from which the model learns. Then we have validation and testing set. So both of these are unseen data for which we basically evaluate our model. The only difference is that the response which comes out from the validation set is kind of used to tune the parameters for the model, whereas the testing set is just kept aside, and when our like estimate is fully trained, we kind of finally see that what's its performance on like totally unseen data. So sometimes the question arises that why do we need to, why don't we just divide it into training and testing set? So the thing is that suppose you divide it into training and testing set only, and so what you will do is you will evaluate it on the test set, and on the basis the response which you get, you will tune the parameters. So but while we do this, there is a chance of the leakage of information into our model, which we don't want, because if that thing happens, the model would be a little biased towards it would be biased towards the test data and won't perform in real world unseen data. Then we have model selection. It kind of depends on the problem we are tackling. So we have plenty of models like for classification and regression. And so I kind of started, so ours was regression, so I kind of started with the basic ones like linear regression, then decision trees, and then finally ended up with using random forest for this. So like each algorithm has its own pros and cons over each other, so we kind of have to see that what all resources do we have to like run this, to run these models, and how much time do we have for the project and so on. Next is a evaluation matrix. So we kind of need something to quantify the quality of the predictions which we are getting from our model. So they are nothing but some mathematical formulas which we kind of use to see that how well our model is performing. So for regression, we have things like mean absolute error, where we this is the the predicted value, and that's the true value, and so on. So yeah. So I kind of use the R-square score for this. So yeah. Next is cross-validation. So it's just a model evaluation technique where we use our evaluation. So right now we decided upon an evaluation matrix, and so to see that how well our model is performing on unseen data, so we kind of run this cross-validation for our data. So this is one of the thing in cross-validation, which is k-fold cross-validation. So here what we do is we take our so we divide it into training and testing set. Then we further divide our training set into k-folds. Like k could be any number, 5 subparts or 10 subparts, and then train our model on k-1 sets and use the final one as a validation set, or you can say that test set or validation set. And then for each iteration, we kind of find the evaluation matrix value. We calculate this value and then average it out through all the iterations. So in the end, we kind of get a good idea whether our model is not we get an idea if it's overfitting or underfitting, things like that. So this thing really helps. And then we have finally things like hyperparameter tuning. So the parameters, they kind of shape the model that how it learns. So the thing is, you just don't need to use the models as black box. You need to understand what's going beneath this. So like in random forest, we have parameters like n estimators, max depth, and so on, which we need to tune before when we train our model. So we have this technique called grid search, which is quite computationally expensive. It's just running the model again and again through all the possible permutation of these particular parameters. We have, I guess, other options also, like randomized, something like randomized hyperparameter tuning techniques also. Also, yeah, one thing. So yeah, so here you see that I use this grid search CV function. So that's a scikit-learn function. So basically we are to choose our to do the parameter tuning. I'm basically using the cross validation score. So like running each model, like choosing a set of parameters, running the model, then finding the cross validation score, and then deciding upon whether to like tune them further or not. And then finally we have curve plotting. So especially plotting the curves between the training, plotting the curves for training and the validation graphs really help to visualize that how the progressive estimator is and how well it's learning. So we have things like so from the graph we come to know like if we plot the validation and training error graph. So if validation and training error both are high, so it's kind of that it's underfitting it, it's not learning anything at all. So then we have if the validation is high and the training error is low, then it's kind of overfitting. So where it's so instead of generalizing, it's trying to memorize each and every data point. So it's not generalizing well. And then we have good fit where the cross validation is where the cross validation or the validation error is low and it's slightly higher than the training error. So this was the graph which I got after training. So the red one is the training score. So these are the scores. I guess the R square values. Yeah, the R square score, and these are the like the training example number. So this is the training graph, and this is the validation graph. So like we can see that the final score of the validation is slightly lower than the training thing. So it looks like it's a good fit. And so yeah, so these were the final results which I got for so the final validation score was 0.95, training score was 0.96, and finally the testing score is 0.90. So you might be wondering by the score, like the testing score is not like it's pretty good for like this initial thing, and the cross validation score is much I would say near to the training score because it kind of gets some kind of bias because we are kind of tuning our parameters on the basis of the cross validation set. And yeah, so these were some of the predictions on some random YouTube videos. So these errors are just like simple original minus prediction or like predicted minus original upon the original value. Yeah. Yeah. Thank you. Questions? Okay, yeah, so one more thing. So I mean the like the performance which I showed you, this can be literally improved more. So I kind of ended up at till random forest. There are still a lot of models which I didn't try, like SVM, neural networks, and all. So that's why I kind of like open sourced my project so that like anyone can try out the data and use it. So like here you have the notebook which has all the data processing and feature engineering thing, and then I have a quite detailed report over here which you can have a look at if you want. Yeah. So that's the link to the GitHub repository, and that's the link to the slide. Yeah. So like you were asking that what proportion should we divide? So like I kind of use that 80-20 ratio thing. So I take so I divide it into the training set is 80 and the testing is 20. Then further from the training, I further divide it into like I showed you the k-fold thing. So I divide into k-folds and that thing becomes a validation set. Or the second option is that we take a ratio of like 60-20-20 or something like that. But the problem is, suppose you have a very small data set. So there if you divide it into like 60-20-20, the proportion which goes for training is pretty low. So the thing is to basically keep it to 80-20 and then run that k-fold cross validation where you basically using one set after dividing it into k-folds, you use each set to validate it. So it, yeah. So yeah, so like these were the two methods. So first was the filter method, so where we basically run some bivariate data analysis. Oh, feature engineering, right. Yeah, so it's like any particular one. So like things are like, so if I talk about this one, so the format which I got from the API, suppose for when was the video uploaded was something like suppose 13 June 2017. So if you see that format, it's not very good to feed directly to the model. So you need to kind of extract as much data as you can from that particular thing. So like we can, so that's why I kind of calculated that how old the video was, like in months.
And you said this is from, this is based on Google's guidelines, you said?
No.
No, okay.
No.
Because I thought you said that, like, for example, the title should be informative. And
Oh, that. Like I read some blogs and forums where the YouTubers, which like the guys who upload the videos, they had mentioned some tricks and tips which they generally keep in mind when they upload the video. So I kind of tried to find that whether I could find such the things which they are following, find that thing from my data. So like so you need to get some domain knowledge, and then you see like how other people are like doing this step. So that thing helps. Yeah.
and what about the ratios at the bottom?
Yeah, so the ratio I kind of tried to think something like so the video view count upon the ratio of view count versus the how old the video was. So something uh, like the rate of increase of view counts per month. So I kind of think something like that. So similarly, other things also.
I have a my question is also pretty much on the feature engineering, so I thought before we move on to the next slide. I mean, all of these features, they're nothing related to the content of the video itself.
Yeah.
It's metadata.
Yeah, right. So you can obviously process the video, but you need that kind of computation power and all. So like that's a good research project to also include the whole video into it and process that thing. But we need a lot of processing power for that.
Understandable. But I mean, just so based just on the metadata, we get 90% accuracy.
So you can't say that like the R square value is not exactly the accuracy. So R square value is kind of like how much like the variation are you like how much variance are you able to capture from your like data, the testing data. So like it should be near one, but you can't like we can't say it that it's the accuracy, direct accuracy, like it's a relative score.
To respond to you, I think there are works that use a neural network to analyze the video in others. But you need a deep learning model. But
Yeah.
I wanted to ask another question still on the metadata, because you are using a random forest classifier, and as a statistical derivative of decision tree, it allows you to inspect and see what kind of features really the model thinks are important or not. Have you done this analysis? So can you give some insights from after the model training, from which features are really important and which are totally useless?
Yeah, so for that, so the thing is that we could easily like visualize the decision tree models, like graph it, but so the feature selection. So like I kind of use the random forest regressor itself to see that which all features were good. So what this does is that it will take a subset of features, then it will like pass through the model and then find out that which was the most relevant one. It will keep it aside. So yeah. So,
Which are the most relevant?
yeah, these were the features which were most like these were the features which I finally trained on. So these were the top ranked features from all the pool of features which I had.
You think that training your random forest just with this features, knowing all the others, gives you an higher square loss than
Yeah.
all of them,
So the
because
thing
I
is,
think that
yeah.
it's not going to be able to cut them. If you properly train it, you should be able to really.
No, actually, if you see that we are like I finally end up using the random forest, and
Yeah,
here
yeah,
itself we are using
it's a
the
decision tree
yeah
document,
that's
so
run.
that doesn't
So
count.
the thing is that you need to do this step. So because sometimes it could happen that there's a high correlation within the input features itself. So that would be a disadvantage to the algorithm we feed in. So we kind of have to see things like if the features are not correlated within themselves, and yeah, so things like that.
Maybe these are extremely small. Means that
Uh,
they don't capture much.
So actually, if you see the report and when you will look at the correlation values, so like I have the graphs of some of the values which are really low. So like I'm sure that they won't be helping a lot in the like the final model. So like yeah, so in total I had like 33 features, but after doing these bivariate analysis thing, you will when you will see at the report, you can see that a lot of them was just like they were not contributing much, a very low correlation. So, right. So like the hyperparameter tuning was done at the final stage when I was doing the modeling. So at the initial stage, for the feature selection, when I use this like this model, I kind of use some some very like I use the default parameters which we have, especially for feature engineering thing. Sorry, for the feature selection thing, and then kind of used then the final parameter tuning was done in that modeling part when we like finally so like I tried that. So like the thing you're saying that it's pretty low, so I kind of tried to train it on 15 data, and from the analysis I got that like all those features were not contributing at all. So if I so I just reduced like removed all those features, and still the performance was same or better. So it was not so like it was the best with only these features. Yeah, sorry, like yeah, so right, I got. So if you so that's why we did our cross validation thing. So in our cross validation we yeah, so we are basically training at some part and then validating it on the like the left out part. And suppose if these values were like very varying, and like some were very high, some were very low, so it or like all were low, so we could we could think that it was overfitting or something. So so especially this thing is used to see that like the model is pretty well training on, so like it's pretty well training. So like the question you are saying that like if you change the training set, so yeah, it should also work. So I kind of took a random training set from my data and then trained this thing. So like it shouldn't be an issue with that.
Also, I noticed another problem in your filter set again, that if your task is to predict how many like a video would get, you are actually using filters that are generated after the video is liked, not
Yeah,
before.
yeah.
And that's why you get such a result, because if I put a dislike or a comment,
No, no, no.
very likely I've already liked
So
it.
yeah, so
You
the
cannot make
yeah, I
that
know,
difference.
like I know. So the if you see the practical usability of this project, it's not much. So it would be good to do the thing till data analysis if we, because so the like counts which we are all predicting is not of much use. You know, if we see in our real world thing. So so the main role of this project would be to till here, so where we can get some insights about it and so on.
Yeah, but
So.
what I'm interested is before I even post the video, whatever is
Yeah,
going
so
to
it's
be
not that.
the
Yeah,
like
it's
that.
different. It's different. It's not that I feed in the data before. So the video should have been posted. So it's just like we are, you know.
That have already been watched, not
Yeah,
before
right,
I
right.
post.
So it's the case when video is already there. We are just evaluating that what like counts it must have. Just like yeah, that's the thing. So it's not like that.
Fantastic. Just
So
putting
that
something-
so yeah, so that would be a like a deep learning problem where we are doing the video analysis. For that we would need all the
Right,
video
even without
processing
doing
and all.
analysis to take only the subset of features you would have at posting time. So title, your
Yeah.
profile, and see
Mhm.
how much you get.
Yeah, right. Yeah, so then we can have those metadata and plus the video thing. Yeah, so it's not.
Forget about the video for now. Just take all the data you would have at posting time. So you don't have the comments, you don't have the dislikes,
Yeah,
you don't have a
yeah,
couple
true.
of,
Yeah,
you don't have the
but
hit
actually
count,
for
and
that
see
case,
what is
yeah.
going to happen.
So,
Because
but for that case, we won't get the data. You know, we don't have any way to get that type of data.
No, just use your same data set and hide the data that first to after watch. Use your same data set and forget about the features.
Ah,
that
right,
are
right.
related
So
to
like you're saying, remove the things like dislike count and
this
those
account,
things now.
watch,
Yeah,
how
right.
many people watch
Yeah,
the video,
sure,
the
yeah.
comments, and stuff like that. Keep the title,
Yeah.
keep the category.
Yeah, we
and
can't do
use a
that.
profile.
Right, right.
For example, how many subscribers? Yes, because if
Yeah.
When you pause, you already have
True. Yeah, we can use that. True.
Thank you, Ayush. If you have further questions, you can find Ayush like during the break or the lunch networking session. And up next, it is a topic about AI learning to drive, which our speaker will give a brief introduction to the reinforcement learning with Python. Our speaker, Mr. Holman Tai, is currently a researcher in SenseTime, an AI company startup provides computer vision products and solutions. He's really passionate in reinforcement learning and deep learning. So may we now invite our speaker, Holman, please.